Welcome to part 2 of the video pertaining to solving quadratic equations. There is a nice formula that you can use every time on every quadratic equation. The catch is you have to have all your terms on one side. A is considered the coefficient of x squared, B is the coefficient of x, and C is the constant. The catch is all three terms must be on one side and the whole thing set equal to 0. If that's the case, then your two solutions can be found by using the formula listed on your page. Negative b value, whatever that number is, plus or minus the square root of b squared minus 4 times a times c. That little part's under a square root, and then the entire denominator, like draw a line under all of it, the denominator is 2 times a. The part under the square root, the b squared minus 4 times a times c, that little part of it is called the discriminant. If its value is positive, then you're going to get two real solutions. If that value is equal to 0, then you will only get one solution. And if it happens to be negative, you will get no real solutions. And later on, we'll discuss what happens if that is negative. You actually get two complex number solutions. A little farther down the road, anytime you find the values or value, sometimes it's singular, of x that satisfies these quadratic equations, if they are real number solutions, they also serve as x-intercepts for the graph of a quadratic function. Quadratic functions will look like either a valley or a hill, but the locations where they cross the x-axis are the same as the answers to these quadratic equations. So let's take a look at an example. Let's look at solving 2x squared minus x minus 1. Now, if all three terms are on the same side, you're ready to start. I'm going to label these A, B, and C, and you'll want to do that with your problem. Okay, setting up the quadratic formula, our two solutions are going to come from the results of negative b, which is negative 1. Note that that b value is an unwritten 1, so it's negative 1 for the b value, plus minus square root b squared minus 4 times your a value, which is 2, times your c value, which is negative 1. All that over 2 times your a value. Be very careful plugging these numbers in. There's three areas that we're going to simplify. The first area is the upper left, negative 1. Well, that's positive 1. The second location is the denominator, 2 times 2. Don't apply the square root, but you can use your calculator to calculate the terms underneath. Don't do the square root yet. Just do the calculation underneath. Negative 1 squared is 1 minus 4 times 2 times negative 1. That's positive 8. Okay, now what does that give us total? Gives us a 9 under there, doesn't it? That's right. So we're going to have equals 1 plus or minus square root of 9 is 3 divided by 4. If I use the plus sign, 1 plus 3 over 4 gives us 1. And if I use the minus sign, 1 minus 3 over 4, that's negative half. But these are the two solutions to that problem. Our discriminant was equal to 9. And because that's positive, we had two real solutions. Let's jump right into another example. 2x squared minus 7x plus 1. All terms are on one side. Everything is set equal to 0. We have A, B, and C. You got to make sure everything's on one side and in order before you label those. But once you do, that's fine. Okay, so we've got x equals long fraction bar minus b plus or minus square root b squared minus 4 times a times c. Excuse me. C value is 1. So we're going to just go ahead and put a 1 there. All over 2 times a, which is 2 times 2. Okay, so make sure your numbers match up from your equation and the quadratic formula from the first slide. Once you're sure you've got them all plugged in, everything's going fine, then you proceed. Top left, 2 negatives make a positive 7. Our denominator, 2 times 2, that's 4. Under the radical, using your calculator, negative 7 in parentheses squared, that's 49, minus 4 times 2 times 1. 49 minus 8, that's 41. Now I'm going to pause right here. That value is your discriminant. (41) also happens to be prime, and therefore you can't square root it out very nicely at all with a whole number. So let's write down our two solutions. Positive in the middle, and then the minus in the middle. These are the two solutions to that equation. Your discriminant is 41. Again, that's greater than 0, which tells us we're going to have two real solutions. Okay, let's do an application with a quadratic equation. The floor of a building is 14 feet longer than it is wide. The building has 1,472 square feet of floor space. Okay, now we're not given any clues about the width of the floor. The length is 14 feet more than however wide it is. So we're going to denote W, and then the length we can call W plus 14. Now remember, area is length times width. For this problem, it's W times W plus 14. That's the length and width given in the description. So area is going to be W squared plus 14W when you distribute. The area of the floor space is given 1472, and we can set that equal to W squared plus 14W. Setting all your terms on one side. Now the only way you wouldn't do that is if you plan to solve by completing the square, but that might prove to be difficult in this problem. You can solve by completing the square, factoring, quadratic formula, just whatever mood you're in. If you do it right, any of those three techniques will work. Okay, I'm going to try factoring, although I don't know if it's going to work. W squared, that's pretty easy. That's W times W. The thing now is we've got to find two numbers that have to add up to 14, but they've got to multiply out to a negative 1472. Maybe take a moment with your calculator and explore pairs of numbers. This one was quite a bit of a challenge. I think I've got the right pair in using a positive 46 and a negative 32. Setting each factor equal to 0, this one's going to give us a negative width. We're not worried about it. The other factor, now that one's going to give us an answer of 32. That's something we can work with. Okay, so the width is going to be 32 feet. That's good. Go back up to your diagram. And I'm going to change colors of ink. If W comes out to 32, and we add 14, that's going to give us 46. And that works just fine. Let me change color one more time. Area is equal to length times width. 46 times 32 is in fact 1472 square feet. So that's the correct answer. We have a 46 by 32 foot building. There's one other skill that I want to show you before I stop this video. In the graphing part of your assignments, feel free to use your graphing calculator as much as you like. Graph the function given, match up the graph from your screen to the multiple choice graphs on your WebAssign homework. Again, feel free to use the graphing calculator as much as you like. There is a skill where I do want to show you is how to write a function in vertex form. When you graph a quadratic function, you're either going to get a hill or a valley. Those are the only two shapes that quadratic functions will produce. There are times when you're asked to write in standard form. Now, standard form, what we're going to do is we're going to change this to a y. And we're going to perform completing the square on this equation. Okay, so let's remember how we do that. I'm going to go to blue. We're going to take half of the number in front of x. Then we're going to square that answer. You always do it in two parts, so that's going to be 16. The perfect square you add to both sides. So we're going to add 16 to both sides. The first answer, the one in blue, you got a negative 4. Negative 4 is what you can use to factor the right side of your equation twice. -4 minus 4 is -8. -4 times -4 is positive 16. And then you re-isolate your y variable. Now what this does is it's the same function, it's the same equation, it's just in a different format. If you go opposite and same, opposite and same, you will get the vertex. What's the vertex? Well, whether you graph this function or the very top one, it will tell you the location of the top of the hill or bottom of the valley, and I'll also show you how to distinguish between those two choices. But let's first plot 4, -16. I'm just going to eyeball it as about there. 4, -16. In the original function, the x squared term is positive. That means the graph will open upward. If the x squared term is negative, it will open downward and give you a hill-shaped graph instead of a valley-shaped graph. That's what the vertex does. That is the turning point. To get a few more details, go back up to the very top of the page. If you were to substitute a 0 in for x, g of 0, that is 0 squared minus 8 times 0, which is 0. That tells us that the origin is another point on this graph. We plugged a 0 in, we got a 0 out. What about that other x-intercept? In the original function, if you were to factor, and I'm going to block this off, you could factor out an x. I'm going to go ahead and recopy this though. If you factor out an x, you're going to get x minus 8 as the other factor. Setting these equal to 0 are going to give you 0 and positive 8. Now we've already got 0, but we don't have that 8 yet. And that's what this number and location give you. Okay, so your y-intercept is the origin, your x-intercepts are the origin and 8. And then one other vocab is called the vertex, or excuse me, where I got vertex, axis of symmetry. Axis of symmetry. It is the x value of your vertex. Axis of symmetry for this problem is x equals 4. It's the vertical line that cuts your graph exactly in half down the middle. That's a lot of information to absorb. Let's do another example, just so we've got a second one to go through. And of course, practice makes permanent, so we want to keep that in mind. All right, first, let's go to standard form. Standard form, we're going to use completing the square as our technique. With the completing the square technique, we're going to bring the 1 over, separating our variables from our constant. So that's going to be y minus 1 equals x squared minus 4x. Remember, part 1 is you're going to want to take half of the coefficient of x. Half of -4 is -2. Squaring that answer or result is going to give us 4. The red number, the perfect square, is what you add to both sides. So that gives us y plus 3 equals x squared minus 4x plus 4. The blue value, -2, that's what we're going to use to factor the right side twice. -2 minus 2 is -4. -2 times -2 is +4. Now, isolating y, we have x minus 2 quantity squared minus 3. Okay, so that's going to give us the vertex. Remember, opposite, same. Vertex will be 2, -3. Opposite, same. This will let us start our graphing. Of course, I encourage you to type the original function into your calculator and graph. This is just a skill that you'll need to have later on where you write these in vertex form. And that's what we did. You have to use completing the square to write this in standard or vertex form. In the original function, your x squared term is positive. That means your graph will open upward and your graph will take on the shape of a valley, just like the previous example did. 2, -3, about there. 2, -3. Now that's the turning point for the valley. I'm just rough sketching. Now these graphs will come with a y-intercept and anywhere from 0, 1, or 2 x-intercepts. Now you can tell by the orientation of this one we're going to have 2 x-intercepts. It's easy to get the y-intercept because all you have to do is plug 0 into the original problem. If we calculate f of 0, that's going to give us 0 squared minus 4 times 0 plus 1. That all totals 1. So 0, 1 is our y-intercept. We have 2 x-intercepts we can get. Now the problem is that original function, if you were to set it equal to 0, it does not factor with whole numbers. So you perform the quadratic function, quadratic formula, where a is 1, b is -4, and c is +1. Again, that all comes from your original function. Okay, so -b plus or minus square root b squared minus 4ac all over 2 times a. Upper left is 4. Denominator is 2. Under the radical, our discriminant is 12. Using your calculator, plus sign. Now you'll have to be very careful typing this in. Let's go 4 plus square root 12. I get 7.4641. Divide that by 2. Okay, so I'm getting, with the plus sign, 3.732. With the minus sign, 4 minus square root of 12. Divide that answer by 2. And you want to calculate the entire numerator before you hit divide by 2. I get a 0.268. These are approximate locations of the x-intercepts. So 3.732 is this one. The other one is 0.268. 0.268. Those are your x-intercepts. Let me try to clean that up just a little bit right there. Here we go. And then the only other thing is the new vocab. It's called axis of symmetry. It's the vertical line that goes right down the middle of your graph. And that one's easy to find. It's always the x-coordinate of your vertex. So x equals 2 is the axis of symmetry.